Hi everyone, and welcome back to another video. For this video, I will continue covering the big idea of creative development as I did in the last video. However, this is going to be more in depth. Yes, as a brief overview, recall that for the big idea on creative development, we ended up discussing on how it pretty much entails collaboration, program function and purpose, program design and development, and identifying and correcting errors. The aspect of collaboration wasn't so much covered since the nature of the create task for your AP exam is pretty much non-collaborative. You have to work on your own, so it's not really worthwhile to end up covering it. And, and such, in the previous video, I ended up covering the last three shown here, the program function and purpose, program design and development, and identifying and correcting errors, with me going a lot more in depth into the program function and purpose, whereas I ended up leaving the last two, program design and development and identifying and correcting errors, for future videos. For this video, I will be covering more in-depthly on program design and development. So to pretty much end up getting an idea on what I'll pretty much be discussing is recall from the previous video that the whole purpose of this critical idea, this idea of program design and development as it relates to creative development, is to first and foremost determine and design an appropriate method or approach to achieve the purpose, explain how collaboration affects the development of a solution. And for this specific bit, because like I said previously, the create task is usually non-collaborative in nature, but I should at least end up amending that to mention that you will be collaborating with one person, and that one person will be me or Mr. Whaley and no one else. You are allowed to end up discussing with your other teammates for ideas, but you are not supposed to outright end up sharing code. The whole purpose of the create task is pretty much a individual project. And the last point for the program design and development is to acknowledge the intellectual property of others when necessary. And I can go more in depth into this later on, but for the purposes of this video, it's not going to be as much of an emphasis. But please do keep in mind that when it's necessary, please cite where you got that idea from. Do not claim an idea as yours and yours only. So to kind of get started on the program design and purpose, a big thing to always keep in mind is the planning stage. In the planning stage, it pretty much entails creating a type of game plan of what you would like to do during the development of a program. And I will be discussing some strategies at the end near the end of the video to that pretty much ends up having a couple of ideas on what this kind of game plan entails and how it will usually look like, along with some guidelines, not necessarily rules, but yes, guidelines to follow in order to ensure that you are developing an appropriate game plan when it comes to developing your program. And a lot of the reasons why is, it helps you get organized in various different ways. I will be discussing more on some guidelines on how to kind of, go through this thinking process on developing a game plan. Because, like, objective wise, time wise, and feature wise, along with the development stack, and I know that when it comes to like the development stack, it's something that you guys may have never heard, but it pretty much ends up entailing different technologies that come together in order to fully realize a uh, program or even an application. And for the purposes of this course, the development stack is quite simply just Python and any of its libraries that you can end up using, which are technology based. Um, and at this stage of planning, you can even end up making use of pseudocode to help out with some ideas for you to be able to figure out and determine any kind of possible pitfalls, or even just double checking on any fallacies that may end up appearing in your line of thinking. And this use of pseudocode is only really, advised to be done once um, a primary language, or just like a development stack is determined. And again, since this is Python, I always like to say that Python is practically pseudocode because of its English-like syntax, and it pretty much is. So you all pretty much already have a step up in comparison to other students, because you can end up easily translating your pseudocode into Python without much thought into it. Another important stage in the development of a game plan is research, and this should be done regardless of the scope or purpose of your program. And in fact, a good thing about research is that it can be done concurrently during planning and communication of writing a program. And it's always recommended if a new technology is being considered for use. And again, this all ends up tying back into development stack. So, yes, as a uh, quick, pretty much thought when it comes to new, different kinds of Python technologies. For example, I believe there is a Python module called uh, Pygame, and it's pretty much a Python module designed and meant to be used in the development of pretty much games done in Python, and it speeds up the overall development of games in Python. So if that is a piece of technology that you are interested in wanting to use, if you want to make something really elaborate in Python, by all means go for it. But again, it is important to do research on it before you start using it. Do not expect to start using it and immediately understand what it does, how to use it, and how to pretty much program with it. Do not assume on any new technology that you can easily and quickly pick it up. Do your research before wanting to pick up a new piece of technology for your project, because just like what this point ends up saying, often not always the case, and it can be done to just take a deeper look into a previously used technology. In this case, Pygame is not necessarily a new piece of technology. It's pretty much a well documented piece of the of technology, so you don't necessarily even have to do a deep dive into figuring out what it does, since there's already plenty of documentation available out there already. And some questions that you may end up getting asked, how have others used this tech? Can it be implemented into a new project? Why or why not? And a lot of these questions are important. Just like going back with the example of Pygame, yes, it has been a piece of technology that has been used by multiple people in the past. It can be implemented into a new project, but again, that entails doing research and making sure that you understand the documentation of it. And in fact, since there's already plenty of examples out there that already exist that make use of Pygame, you may as well use it to gain inspiration from others, investigate other projects that may be similar to obtain possible insight on how to tackle your project. And this is an important bit. I'm not saying go out there and copy someone else's code. Be inspired by their code. And in order to be inspired by someone else's code, you have to understand what they are doing. And in order to understand what someone else is doing in Pygame, you need to understand how Pygame works. So don't assume that to pretty much I am not saying go ahead and look at someone what other people have done and copy that code. Do not, under any circumstances, do that. I do not support it, but I do end up supporting being inspired by what others have done and possibly adapting that inspiration into your projects one form or another. Another important aspect to the, the design of the program is communication. Again, this normally entails if you are working with more than one person, but since the create task is more of a solo project, you're not really going to be working with anyone else outside of either me or Mr. Whaley when it comes to reviewing your code. And this step entails, just like with research, it can be done concurrently, and which just means it can be done at the same time as you are developing your plan, your game plan for your program. And this is a crucial and important aspect of writing a program, and the reasons why is because if you consider the parties of you, the student, me and Mr. Whaley, it pretty much ensures that everyone on the team, and you can think of Mr. Whaley and I as part of your team, it makes sure that everyone on that team is on the same page when it comes to the goals you want to achieve with your program, any other side objectives that you would like to end up meeting, any kind of technology use, some kind of expectations, and most important, deadlines. This is a really important aspect when it comes to your create task. There's only limited amount of time that you can spend working on your create task, and having set deadlines, because the deadlines doesn't necessarily have to be, the final uh day that you can end up yeah, the final day that you can end up submitting your project. That's like a hard deadline. You also need to have other deadlines. Can I implement this, functionality? Can this be done, etc., etc.? You have to kind of like also keep in mind possible upcoming deadlines aside from like the hard submission deadline. And in fact, I encourage everyone to give themselves a minimum 1 week buffer between the hard submission deadline and before you want to actually complete the project. Never ever complete your project on the same day as submission. That is a recipe for disaster. Always complete your project at the minimum 1 week before the submission deadline. And this is just to ensure that other people can test your program and make sure it is working as intended and there are no surprise errors. And this is important. And along with all of that, there's also the important aspect of the decision making process, which is effective throughout development. You are pretty much managing your own project. You are able to decide what your goals are, what your objectives are, what technology you want to use, along with the kind of expectations that you're expecting from your application, and not only from your application, but also to your team. So please always make sure that you are involving everyone on your team in this process to make decisions. Normally, it's best not to do decisions on your own without telling your team. It's always good to, communicate every decision you're making, not necessarily for approval. Mr. Whaley and I, we're not necessarily going to give. Don't think of this as like us giving you a stamp up of approval. It's more so um, involving us in the decision making process to make sure that you're not setting yourselves up to failure with too massive of a project. So it's important to always keep us in the loop in this kind of decision making process. And this is just kind of like an additional bit I ended up throwing it. It's not necessarily going to be applicable to everyone, but if you are interested in making use of GitHub, and just to kind of like quickly explain, GitHub is a remote it's pretty much like a remote repository, and you can think of a repository as a external server meant to hold and kind of like maintain a stable state to your code. So you could actually end up collaborating through GitHub. You just pretty much create a remote repository and then keep all of your code there, and the code could end up evolving over time. And it's also a really effective way of pretty much version control, and yes, being able to communicate issues and any kind of bugs encountered, uh, on sites such as GitHub, which does end up having a lot of features regarding bug control, and also Stack Overflow when it comes to figuring out, hey, what's going on with my program. Now, this is, I know I ended up covering planning, research, and communicating, but this is also another equally important aspect into the overall planning process, or not necessarily the planning process, but yes, the idea of program design and implementation, how to actually implement what you want to do, and this ends up involving writing code. And here is the biggest, most important point I will ever have to say on this whole video. Comment as you code. I cannot stress this enough. Comment your code. Why? Good code is always self documenting. If you write a piece of code that is pristine, that is clear, that is concise, good for you. That is self documenting code. However, don't think just because you write the best line of code that you should not write a comment. Always write a comment. And this comment should end up focusing on a high, it should serve as like a high level overview on how the program would end up, what the program does. Just a high level overview. You don't necessarily have to go deeper into details because guess what? The code already does that. You just want to explain what the code does in as few words as possible, because if your project turns out to be complex, and for your skill level these projects will be complex, it's usually often the case that code will become messy. I have seen plenty of code in the past from previous students that have been messy, and in the past I didn't make it a requirement to I didn't make it a requirement to comment, their code. But I think moving on, I will discuss this with Mr. Whaley. I will make it so that now you will lose points if your code is not being commented. Yes, as a way to have everyone, uh, comment your code. And if not, and if that's too negative, one way I can end up doing it is you receive additional points for commenting your code, and I will be the judge on how much points you will get based on the quality of the comments of the code. And I'm all over here talking a lot about comments must always write comments, but I didn't really talk much or go much deeper into the purposes of why comments must be written. First and foremost, it helps organize your thoughts in a coherent fashion that serves as a guide on accomplishing a specific portion of code, such as an important function or method. I have done this when I have done really complex programming projects in the past. If I've gotten to a point where I just don't know what else to do because I'm like stuck, I comment. I comment on things to pretty much describe my thought process that pretty much ends up describing. And remember, this is all at a high level. I am just describing how a portion of code should work. I am not talking about exactly how it works because the like I said before, the code already does that. Commenting is good to keep your sanity in check and make sure that you are not going to go crazy looking at code and not being able to figure out why your code's not working. It is a good debugging process, especially if you are encountering errors. And another purpose is, it helps in documenting the code, especially if the comments are included for every function or method that is written. If you write a function that's really complex, I'm not going to be able to understand what it does at first glance. I won't have to like actually sit there, look at the code a couple of times, and then figure out what you are trying to do. If you don't comment on the purpose of the function, then it's going to be more difficult. And going back to good code being always being self-documenting, you can even end up just writing as the function name something really descriptive. But even though it's descriptive, the name of the function, I would still suggest to comment your code. Never ever leave any pieces of code uncommented. I'm not saying comment every single line. I'm just saying comment huge chunks of code, especially chunks of code that you believe will be hard to understand for other people. So it is always important to keep that in mind. And and comments will always be included regardless of language, even if those languages are Python, HTML, and CSS. Yeah, Python is pseudo-like, it's English-like, but yes, because it's English-like does not excuse you from not including comments. Always include comments, and at the end of the day, employ good and clean style coding habits for readability. Thankfully, Python already enforces that. If you end up using spaces for indentation instead of actually indenting, guess what? Python's going to throw a fit. It's not going to understand what you're trying to say. So to an extent, Python helps you develop these good and clean coding styles when it comes to yes, programming anything. So, and here's the fifth aspect of this whole process, testing. It is always advised for testing to be done concurrently, or concurrently meaning at the same time as your program is being developed. But wait, how can I do that if my program's not fully completed and I'm not able to test it? Oh, that's easy. Because there exist three types of testing, if you remember from my previous video. There is, and all of these approaches are pretty much, bottom to top. So pretty much we start with unit testing, and unit testing involves just testing out one unit of your code. And this unit of code can end up pretty much ranging from just like a simple function to just like, testing out the behavior of a class, like of a class definition. And this is what unit testing entails. You're just testing small individual chunks of your code. Not everything, but just small individual chunks. The next step in testing is integration testing, and this ends up involving yes, pretty much making sure that you can start connecting these small little units together and make sure that they are working and playing nice with one another with no issues. Because if there's an issue between two different functions that end up relying on one another, there will be problems in your program, and you need to figure out what the problems are. So understanding how to do integration and doing integration testing is just as important as unit testing, and equally as important is end-to-end testing. And you can think of end-to-end testing as uh, the full-on process of just testing your program, from start to finish, and making sure that you are not missing out on a key detail. So but like in more complex projects, end-to-end testing is just pretty much making sure, because in large complex projects you're going to have like different source files. You want to make sure like the different source files pretty much end up playing well together with one another from start to finish. So it, please keep in mind these uh, three types of testing. I may not be able to help much when it comes to developing, these kinds of testing for everyone, but because at this point it's good practice to start looking at this kind of testing. And in fact, depending on how things were done in the previous semester, you may have received tester programs that run your program. And in fact, that is one way for you to look into the code and understand how testing can be done, because a lot of those tester programs, to an extent, can be seen as unit testing. It's just a way for you to pretty much make sure that your functions are working as intended. This is a form of unit testing. So I encourage everyone to go ahead, crack open those tester programs, and take a look at it. They are written in Python. Take a look at it and understand how it works. Get inspiration from those tester programs for you to be able to develop uh, tests for your create task. And I pretty much already talked about like a lot about why testing is important, but just to, reiterate, it fundamentally ends up ensuring that your program ends up working as intended, that there's no random behavior, or yeah, pretty much like random behavior, which can end up including errors in your program. And to an extent, this also applies depending on like the type of testing method that you are using, whether that's unit testing, integration testing, or end-to-end testing. And you always have to be on the lookout for edge cases that may cause the program to fail. You want to be able to deal with these edge cases gracefully. And a really nice way of dealing with edge cases is by using if statements to end up preventing the program from crashing if something is, kind of like out of bounds when it comes to writing a program. So now I'm gonna pretty much start talking about a example. There will be a follow-up video to this video where I will be actually employing a lot of these tactics and methods that I'm covering right now. So I would highly suggest everyone to take quick notes on this example. This is just a brief high-level overview of what I will be covering, and in this case, yeah, of the program I will be developing. And in this case, the program I am developing pretty much entails finding solutions to quadratic equations. I'm not sure if everyone has taken Algebra 1 or even Algebra 2, but that's okay for the purposes of this example. That's why I am encouraging everyone to take notes right now. And a big reason why, so to pretty much continue with this example, a big reason why it's important to obtain solutions to quadratic equations is specifically because a lot of real world problems can be modeled by parabolic functions. Parabolic functions are quadratic equations. So when it comes to, throwing a ball, even if you throw a ball straight up, guess what? It can still be modeled by a parabolic function if you end up kind of having your x-axis be the time in seconds that have passed by since after the initial throw, and the y-axis being the height of the ball covered. Even if it's, straight up, you will see a parabolic uh, function, a parabola. So this parabola, pretty much models a ball being thrown straight up. Uh, and this also has much more applications outside of, simply throwing a ball. That's just kind of like the easiest example I can use to explain why finding solutions to quadratic equations, matter. And the standard form of quadratic equations usually will take on the form of ax squared plus bx plus c, where a, b, and c are constants, and all of that is set equal to 0. So, and here are some methods of solution for solving these quadratic equations. One method is factoring the quadratic, and for those that have taken Algebra 1 or are in Algebra, whether they've taken or are currently in Algebra 1, because this at least has been exposed, you guys have at least been exposed to some of these methods of solution as early as Algebra 1, you may remember factoring. Yes, factoring is a method of solution to obtain, the zeros of your quadratic. However, when it comes to implementing in a program, that's a bit more trickier to try and and obtain actual factorable solutions to your quadratic, because not every single quadratic equation will play nice when it comes to factoring. And sometimes it's just going to get downright disgusting. A lot of these factors, especially if the equation will not play nice when it comes to factoring. So, okay, if we can factor, well, we can always complete the square. That's another method. But the thing with completing the square is that it doesn't work all the time either. But the one method that works 100% of the time, regardless of what you're working with, is the quadratic formula. And this is going to give you solutions every single time, regardless of what your values for A, B, or C are. And it's pretty nifty, and it can be implemented in programming quite easily. And it's actually one of my favorite examples when it comes to demonstrating problem solving in programming. So, just to kind of like briefly explain the quadratic formula, it pretty much helps provide solutions to the quadratic equation, and in this context, solutions are the same as the zeros or the x values where the parabola touches the x-axis at y equals 0. If you look at a graph of a parabola and you look at the parabolas that end up, touching the x-axis, they always touch the x-axis anytime that y is equal to 0. That is why we end up setting, pretty much like in the standard form here, we end up setting the equation equal to 0. And it's a really nice way of providing solutions to. Oh, that's repeated. My bad on that. So apologies for kind of like having that repeated line, but just to kind of like keep the ball moving forward. An important aspect of the quadratic formula is the discriminant, or pretty much the small little equation underneath the square root. Because if just to pretty much end up, explaining the reason why this piece is important, I do end up, explaining it in the bottom, but more to be more mathematically precise. Remember, you can only take the square root of things, whether, yeah, you could take the square root of anything that is 0 or positive, anything that is greater than 0. If it's negative, that's when you start going into complex solutions. So when the discriminant d is positive, that means that there will be two real solutions. If the discriminant d is 0, then that means that there's only one real solution. And when d is negative, there will be a pair of complex solutions. And in this case, trying to produce results for complex solutions when it comes to programming can be a bit difficult, but it's not impossible. It just takes a matter of figuring out how to end up making use of it, and this does require some mathematical background. But that's why I end up having the quadratic formula right there at the bottom right, just as a way for everyone to remember how it works and how it functions. So let's start drafting up our game plan. So we know that the discriminant d is important because it helps in how to output specific things. If I go back, recall that, pretty much the discriminant is responsible for telling us whether we have two real solutions, one real solution, or a pair of complex solutions. So understanding that the discriminant d is important will help us in figuring out the rest of our flow of the program and trying to figure out how to end up implementing it. So here's a quick design question for y'all. Will user input be considered? Well, this is going to depend on the overall design of the program, and pretty much also dependent on the experience of the user. If the user is not as experienced with programming or understanding how a program works, the simplest approach Yes, ask for user input via the input function in Python. That is the easiest approach. A more advanced approach is you can use a file input. You might be thinking, wait, how can this be done as a file input? And I will show that in a in the next video when I'm actually starting to develop the program. Another design question: how will results be outputted? Well, again, this is dependent on the overall design of the program, and it also ties back into the experience of the user, or in other words, the user experience. Easiest way, just print it out to the console, the output. More advanced approach, file output. And again, this all depends on what the user is comfortable with and what the user wants. And this is part of communicating. Sometimes you do want to communicate with the person that you are developing a program for to determine what they want. But in this case, we can try on developing a program that is suitable for like users of any skill level, and we can even set it up to where we can have a file output or not. And this is all going to be shown in the next video. Again, I would suggest everyone to go back and explore uh, pretty much this whole overall example overview, so the previous 3 slides. And if you like, just go back to the video, start taking notes again, because these notes will help better understand the process when it comes to actually implementing the quadratic formula in a program. So see you all in the next video.